This video is intended for you to learn how to create constructions involving inscribed polygons. The most popular polygons that these questions will ask you for are for triangles, hexagons, or even a square. To be inscribed doesn't just mean inside. Inscribed refers to actually touching the circle's circumference. So what we're going to do is learn how to construct these types of shapes inside of a circle using our compass, and we need a straight edge or a ruler. So the first question I have here is asking us to create or construct an equilateral triangle. Equilateral means that all the sides are the same length and all the angles are the same measure, which would be 60 degrees. To create this triangle inscribed in our circle, notice that we're given O to A as the radius of the circle. That's like a head start for us. What we're going to do is measure the radius with our compass. I'm going to put my needle on A and the pencil on O and have that measurement. So give me a sec while I'm just getting myself situated there. So again, my needle is on A, my pencil's on O. I can make like a stray mark right there so I can see that my compass is that measurement. What I'm going to do is kind of like move my pencil of my compass outwards so that I'm intersecting the circle to create a point there. That intersection shows me that that's where my needle should go one more time. Then isn't that how we started? I put the needle on A and we measured and we made an arc to go on the circle. So my needle now is going to go on that point that I just created. And what I want to do is create that same stray mark. Notice I'm intersecting the center of the circle and I'm intersecting the circle circumference. That point is where I'm going to put my needle next. And I'm going to keep going all around the circle until I can't no more. It kind of makes a pretty picture. So again, I'm going to put my needle on that new point I'm creating, moving my compass out to hit the circle circumference. You'll know when you're done, when you can't do this anymore, which is going to be right now. Notice that after I make this last mark, which should have intersected here if I did a better job, I should have intersected point A, but that's okay, I'm really close enough to it. So going back, the first step was to measure the radius of the circle, make that sway or that arc mark to intersect the circle circumference. Now what we have are 6 points, 1, 2, 3, 4, 5, 6 points here on my circle. And triangle doesn't have all 6 points. A triangle only has 3 angles or 3 vertices. So what we're going to do instead is connect 3 points, but not any 3 points. What we're going to do is connect every other point. I'll start with point A and connect it to an opposite point that I created. So I skipped over one that's there. I'm going to do it again, connect another set of non-consecutive points, and then connect it to my original point. And there you have it. That's an equilateral triangle inscribed in the circle. Sometimes the question might ask you to name the triangle. We already started out with this point as A, so I'll just call a triangle A, B, and C. That's an equilateral triangle. I could put my tick marks to show that all these side lengths will be the same. I have another construction for us. This time I wanted us to construct a regular hexagon inscribed in our circle. A regular just means all the same sides and all the same angle measures. That's why it was called an equilateral triangle before. So now we're just calling it a hexagon so that you know that all the angles have to be the same. Once again, this question now is asking us to label our hexagon with certain letters. So that's really important because if you forget that, points could be taken off for not completing the construction as you were told to. So like we did in the first question, what we did was we measured the radius of the circle. Same idea, what we want to do is measure the radius of the circle, but we were not given any point on the circumference. So I'm just going to start with any old point. I'm going to call it A, since we did need to have the letter A according to the question. I'm going to go ahead, put my needle on A, put my pencil on O, get that measurement of the radius of my circle, and I'm going to start by swaying my compass outwards so that now I have a new intersection point with the circle circumference. And you're gonna keep going around like we did previously. Go around the circle. I think I need to remeasure what I just did because I moved it slightly. So again, if that ever happens to you, once again, you could go back and remeasure what you did just to make sure it's good. And now my pencil goes to that new point, make that arc mark. See how I'm kind of making it slightly different? You don't have to like intersect it completely. As long as you're intersecting the circumference of the circle, that's what's important. So go around your circle until you can't no more. Because if you think about it, in the last question, what we did was we made 6 points on the circle circumference. And once again, I have another set of 6 points. So that's A, this is point B, this is point C, this will be point D, point E, and point F. This arc should have really intersected A. That shows me that I probably moved, like I said before when I was doing it, I might have moved slightly, but that's okay. If anything, I could erase this, remeasure it, and do it a little bit better for next time. So I'm gonna go back and remeasure what I did and go back to here and redo that arc. Okay, and again, it could be slightly off. It's not the end of the world if you didn't hit it completely. Okay, and what we're gonna do is connect all of these points one more time from A to B, B to C, and so forth all around your circle. And again, this will be an inscribed hexagon. A hexagon has 6 sides and all 6 equal angles since it's regular. If I wanted to, with my ruler, I could go ahead and measure all the sides and they should give us the same length. So there you have it. The last question on the paper for today, I wanted to show you how to construct this type of polygon. What we're gonna do is inscribe a square in a circle. So the first 2 constructions involve the same technique. This third construction is actually a different technique. So if you did not watch the first video of how to create a perpendicular bisector, that might be helpful to watch that video first. An inscribed square is different because a square has right angles at its corners. So that's why we need to have right angles instead of a 60-degree angle or a 72-degree angle. So for here, we have a perfect right angle. We need perpendicular lines. So what we're going to do is that two-tailed construction, or two-tailed fish, I should say, construction. So again, if you didn't see that video, maybe go watch that first. So first thing, what I want to do is create a line segment to bisect. This line segment that I just created is actually called a diameter. It's going through the center of the circle. So this diameter will now have endpoints. It didn't say how to label it. Maybe I'll just call it AB just for reference purposes. So I have diameter ATB. AB is where I want to find the right angle that would create that. So I know that T is the midpoint. We want to find the right angle to create that, or that goes through that midpoint. So what we're going to do is measure A to B. And if you remember that construction, we want to be more than halfway of the line segment. So my compass is pretty good. You don't want to be the full length. You don't want to make giant arcs. And if you don't make it more than halfway, then you're going to not intersect at all. So you have to be really careful there. So let me go back. My ruler got in my way. All right, so what we want to do is put our needle on point A and be more than halfway of the segment and create an arc. Keeping the same compass width, don't change your length. Put your needle now on point B, the other endpoint, and create another arc. Make sure your arcs are long enough so that they do intersect. So I see that my intersection will be here and there. Those 2 intersection points along with point T could be connected. Now you might be saying to yourself, where is the square? Well, if you think about it, one of the properties that you probably learned in your geometry class is that a square's diagonals are perpendicular. So these are my right angles, but this is not the square just yet. What we want to do is take a look at where we touched the circle, where we inscribed it. Maybe I'll call this, I don't know, CD. So now what we're going to do is create this square. This square's name would be C, B, and D. So let me finish doing it and then I'll show you one more time on how I named the square. So this square would be called A, C, B, D, going in the order that I just created. And again, what we constructed basically are the diagonals of the square. Because again, a square has perfect right angles and they are bisected. So these are 3 popular constructions of how to inscribe polygons.